Hi guys, so my name is John Marie DeJagger, and today we're going to be doing our 5th interactive advanced presentation, and we're going to do something a little bit fun. It is going to be with a couple pennies that I already have laid out right here. So before we get started, let's just talk a little bit about what we're going to be looking at and why that happens. So as we all know, the Statue of Liberty is, of course, known for its ionic blue-green tint. And actually, a lot of people might not know this, but the Statue of Liberty originally was not that teal color. It was actually a very pretty copper color back in the day when it was just built in 1886. So now what exactly happened to it? So one thing that is important to know is that the surface of the Statue of Liberty is actually covered with copper sheets, which is the same element that it actually makes up the little pennies that we have today. So why is it this green tint? So over about 20 years of exposure to air, the Statue of Liberty actually started to change color from the shiny new penny color to more of the green that we see today. So it is actually explained through a chemical reaction, and that's what we're going to be looking at today. So the thin copper sheets, as it that you can see on the outside of the Statue of Liberty or even the outside of a normal copper penny, actually reacts with oxygen in the air that actually produces that green oxide or that green copper oxide tint that we see. So in the Statue of Liberty's case, the copper oxide actually continues to react to make copper carbonates, copper sulfide, and copper sulfate. So these three main compounds produce that blue-green color that we see. Now, of course, with pennies, it is not to that extent because clearly some pennies, like I have right in front of me, clearly is not green. However, if you look very closely, sometimes you can see green pennies. I know I've had several over time. So let's take a look a bit at our penny. So if you look close at a penny, it appears to be pretty copper. The one I have in front of me is a little bit dirty, but unless if they are extremely old, it is actually a combination of metals that include copper, zinc, tin, nickel, and steel. So in this presentation or this experiment, if you have a little bit of an older penny, which I know nowadays those are a little bit rare to come by, this experiment might actually work better for those. But for today, we're just going to be using one. I'm pretty sure this one is of 2010. All right, so one reason that most pennies today contain zinc is because the metal has a high resistance to atmospheric corrosion, which is why, kind of like the Statue of Liberty, that zinc element that's within it helps it not turn that green color, it helps it not rust. So the copper in a penny kind of sometimes turn dull when it is exposed to air. So this reason is because the copper atoms will combine with the oxygen molecules to form copper oxide, which is what we talked a little bit about earlier with the green color of the Statue of Liberty. And in this chemical process, it is actually called oxidation. So a simple reaction, so for each of the oxygen atoms in the oxygen molecule will actually combine with the copper atoms, and then as a result, the two molecules of copper oxide will be formed. So when oxidation occurs in iron, the result is called rust. So normally you see this with either a rusted belt on a bike or a rusted pipe outside. So that's kind of where that's common, especially that you can see outside. So a penny with a high copper content won't actually disintegrate in air because once the surface layer of copper oxide is formed, it will actually prevent further corrosion. So just a little bit of background, but these are a couple of things that we are going to need for this experiment. So right here in front of me on this side, I have a bowl of water, which we're going to be using towards the end. I have my vinegar. You will need some vinegar. And then, of course, you will need pennies, which I have in front of me. And then you will need some salt. So first thing you're going to do is you're going to fill your empty bowl, which is this one in front of me, with vinegar. So let's do that. I am going to fill it just enough so I know that my pennies are going to be underneath. The second thing you're going to be doing is you're going to be taking some salt. I did not measure this out, but I have looked on the internet and some people say about a tablespoon. Paper. And then, of course, go ahead and stir that around. Let me grab. You're going to go ahead and just stir that. Make sure that it is dissolved. So you kind of have a vinegar salt solution. So let's go ahead and stir. All right, so this is actually the really cool part. It happens extremely fast. So let me just pull my notes out real quick. All right. So once you have done that, you're going to throw your pennies into the solution. And then you will watch it work. So some of the reasons why I see mine is not doing extremely well. Oh, there, it's starting. Why it might not work very well is what I mentioned, that it could be because of the type of penny that you are using, as well with the type of vinegar. I have noticed that some vinegar is better than others. So that could also be a reason. So once you have watched that, I can see it work a little bit on that penny for sure. Not as intense as I had hoped for, but it does work a little bit. So the combination of vinegar, which is, as we know, a weak solution of just acidic acid, and then the table salt, which is just sodium chloride, will actually help dissolve that copper oxide that has formed because of oxidation, which can also form the blue copper 2 ion, which is soluble in water, which I thought was pretty cool. When the salt and vinegar are combined, they will form a very, very small amount of hydrochloric acid. And that hydrochloric acid will then actually help remove the oxidation from the pennies. And then, of course, by removing the copper oxide, that will be the chemical change. And so then the penny will become shiny again. So that is the experiment. Once they have spilled, oh, that one's pretty. Once they have been in the water a little bit, as you can see, it is a lot cleaner. You just put it in the water. And there's the second one. Third one. So those three worked very well. Honestly, I must say that this one did not work very well. However, I do believe it is because it was not actually copper oxide on the penny. I do think there was a little bit of dirt on the penny, which you could potentially just get off by scrubbing it. And then this one worked pretty well. But the same thing I would say is those pennies might have just been dirty because of other factors such as dirt or other things other than copper oxide. I hope you guys enjoyed this, and I hope you guys have a blessed day.